Why do climate models sometimes disagree? Have you ever wondered why different climate models can show different predictions about our planet's future? It's a fascinating question that reveals a lot about how scientists study climate change. Let's break it down. Climate models are complex simulations that attempt to representing Earth's climate system. This system includes many interacting components, such as the atmosphere, oceans, land, and ice. Because of this complexity, models can sometimes produce differing results. One reason for these differences is natural climate variability. The climate naturally fluctuates due to factors like ocean currents, volcanic activity, and changes in solar radiation. These variations can lead to regional differences that models may capture in various ways. For instance, some models might not accurately reflect the strength of certain climate fluctuations over decades. Another factor is the differences in forcing inputs. Climate models relying on external influences known as forcing agents. These include greenhouse gas concentrations, solar radiation, and aerosols, which are tiny particles in the atmosphere. If there are uncertainties in how these factors are estimated, it can lead to different outcomes among models. Feedback mechanisms also play a role. Feedbacks are processes that can either amplify or dampen climate responses. For example, when ice melts, it reduces the surface reflectivity, causing more heat to be absorbed and leading to further warming. Models differ in how they simulate these feedbacks, which can affect their temperature projections. The scale and resolution of models can also cause disagreements. Some models operate at a finer scale, capturing detailed regional phenomena better than coarser models. However, higher resolution requires more computational power and may still involve approximations, leading to variations in results. Additionally, model structure and parameterization contribute to differences. Some climate processes, like cloud formation, occur at scales too small to be directly simulated. Models use parameterization, which are simplified representations based on observations, to include these effects. Different approaches to parameterization can lead to divergent results. To address these uncertainties, scientists often run multiple simulations with slightly varied initial conditions. This method creates an ensemble of model outputs. By averaging these results, scientists can identify common trends and reduce disagreement, but individual runs can still show variation. Despite these disagreements, climate models consistently agree on major trends. They indicate that global temperatures are rising, warming is amplified in polar regions, precipitation patterns are changing, and sea levels are rising. These consistent findings are essential for informing policymakers and communities about potential future impacts. Understanding why models sometimes disagree helps scientists improve them over time. This ongoing refinement increases confidence in their projections, allowing us to better respond to global climate change. By recognizing the factors that lead to differences, we can interpret model results more carefully and use them effectively in our efforts towards sustainability.